Well, hi, welcome to my shop, and thanks so much for joining me here today. I'm going to be working on this Heathkit signal generator someone was kind enough to give me, rather than toss into the garbage. Yes, don't toss stuff like this into the garbage. Find somebody who'd like it and give it to them. So here it is. So it's kind of nice, kind of neat looking. I just like the balanced look of it. Heathkit. Let's see, it looks like it's an RF only. Oh, it says AF out. Bands 320. It's kind of funny how they number it. I guess it's 100 to 320. Yeah, 10 to 32. Oh, maybe there's a switch here that takes it from. See, that says RF. This is AF. Well, here we are. External modulation in or AF out and RF out. So it's like two signal generators in one. And let me guess here. Let's see, this is a bit of a loose knob there. External modulation, internal modulation, or AF out. So if you flip it this way, you have some kind of internal modulation going on, and it's available here if you want it. Doesn't look like you can change the frequency of the unless you have an external modulation going into it. I think that's what's going on here. So we've got 1, 2, 3, 4, 6 ranges. It's 110 megacycles. Ooh, this goes much higher than anything I've got in my shop here. Most of my stuff's ending 20, 30. I think this guy goes up to 50. And this one goes up to 100. So I got a little more range with this for my shop. Not that I do much up at that frequency range. Attenuation, just 3 settings: low, medium, and high. And then you have a fine adjustment. A little sticky. Ooh, very sticky. That's nice. Got a geared wheel here. Feels really nice. Very nice. Model IG-102. Okay. So let's just pop these screws out and see what's inside. This is a very light. It's not really light. Trying to judge whether it had a transformer in it. I'm pretty sure it does. I guess with a piece of test equipment, you kind of want a transformer inside. In the power supply, it'll give you isolation from the line if it's done that way. Boy, the paint's just flying off this thing. Okay, 2 screws to lose. I'll put them there in my special spot. There's something more holding this together? I don't think so. Somebody didn't bother sticking that on. Just stuck it in here. Oops. Okay. So, a couple tubes. 12 AT 7, 6A and 8, not uncommon tubes. some bad. These capacitors have a bad reputation. This type here. Looks like there's only 2 of them. There's a silicon diode there. Don't see any evidence of anything going wrong. It's really nice and clean in here. Let's take a look at the power supply, how they've done it. See the power come in. Goes to the terminal strip here. No, down here. Yeah, comes in, goes to the terminal strip here. You can see oddly enough, 2 wires here, a green and a black one, attached on this terminal going into the transformer, and a red one over here going in the transformer. Oh, that's not right to the power. Oh, there must be a switch involved, of course. So probably some wires I'm not spotting traveling up to the switch, the on-off switch, which is here. Edges here. Yeah, there they are. A twisted pair of wires. Yeah. Okay, then so we have some capacitors right across the power line, but these are highly reliable capacitors here. Not too worried about those. Not too worried about any of these really. Even these ones look to be, all looks to be in great shape. I think we should operate it. I really do. Don't see any reason not to. So we need some way of knowing that it's operating aside from the red light coming on. Oops. So it came with this wonderful cord here, which appears to be pretty darn stiff. Oops. Let's just see. That's not too bad. Yeah, it's just been hanging in one position too long. So we'll start with the RF side here. Okay. Low. And I think we should just put it right on the oscilloscope. I think it'll be the easiest thing to do. We'll see right away what's coming out of it. If anything. Oh, that's not at all the right connector. So just before I hook it up, we'll do a couple of tests here for leaks to the chassis. Now, I'm not familiar with these tests. I'm teaching myself to do them. I'm liable to fail the first few lessons here. So I'm going to plug straight into here. There. Oh, it's not looking terribly good. That would be a step on. I imagine somebody stepped on the cord and did that. My first repair. Hey, here we are. Perfect. Just thinking stupid things about this while I'm doing it. Here's a stupid thing. When I was a kid, I had a friend named Brian. I go to his house. Go in his house, you know, 11 in the morning or something like that, and the lights would be on. And I'd say, what? I start turning them off, because why you got these lights on? I'm turning them off. He goes, what are you doing? Don't turn them off. Why not? Because my dad told me that when you turn the light on, there's a rush of current that uses more electricity than the light uses the rest of the day. So once you turn it on, you should leave it on, because every time you turn it on, the power company's charging you a ton. And these people were turning their lights on and never turning them off. There you go. Yeah, and I knew better. I knew better at that time, but I didn't go talk to his father. I didn't really know his dad. I knew nothing about his dad. Just a kid. But, okay, don't do that. Don't leave all your stuff on because you think you're saving power. I mean, the absurdity of that on every level. turn this off for now. This is an unpolarized plug, which has caught my attention. My phone is in my pocket where it shouldn't be. So I apologize if you've been listening to my phone chirping on the video. I'm going to go in here, switch this guy on, and take a regular voltmeter, going to read the chassis to ground, something I usually do. But then I want to use the feature in this meter where it can detect leakage current, supposedly. That's really what I want to experiment with. So we're in like that. This is off. This is on. We're hitting it with like 110 volts or so. Okay, so we're checking the on-off switch. It's off. That's good. And we want to get my voltmeter ready. I'm using the ungrounded voltmeter here. And I wouldn't be surprised if this meter gives me 30 volts or something like that. So switch is off right now. I'm going to clip lead one to ground so I don't have to worry about it. I'll use the black one, eh? Okay, and we'll clip it to a ground terminal. Something I know for sure is clipping. Yeah, you'd think there'd be lots of stuff to clip here for sure. Come on, it must be a good spot. Okay, it's grounded for sure. Grounded to the power system. Grounded to the... Okay, first of all, have I got any voltage? Do we bet? 17 volts is what it says there. Now I've got it plugged into an isolation transformer. I did plug it into an so we're going to move it into a regular outlet and do this again. But let's just reverse the plug and see what we get. It's really, we shouldn't really get anything, I think. About the same voltage there, 18 volts. Okay, now we're going to plug it into the real normal outlet. That means one side, one prong is going into a grounded terminal. What do we get now? Now we're cooking. Now we're getting 60. We're getting half of 120. Okay, this is a more having it plugged in here and doing that test initially is a little bit fake. Chances are, we reverse the plug, we'll get another 60 volts or so. We're going to get the other 60 volts. There's the other 60 volts. So that to me says the capacitors involved with the power line are in good shape. They're equal. That's why you're getting 60 and 60. I've seen them. They look good. I have not looked at a schematic or anything like that, so I really don't know how they're done. Now, let's see if we can spot a chassis connection. This guy is switched on. No, he's off right now. But I got it. I have it plugged in. Let's unplug it. Okay, so I'm looking for various things. So here's a connection to the chassis here. Here's one here. You know, that's almost enough already to know what they're doing with it. Let's see what else. Here's another one down here. These are done with, they're soldered to terminals that are screwed down onto the chassis, and that can be a bit of trouble. So, okay, that's good. Now, what do I want to try now? I'm going to turn the unit. Oh, I don't want to turn it on until I have it. I'm going to turn it on. I don't want to plug it in a regular outlet and turn it on. I'm trying to avoid that. So we're going to put it in here. Power's on. Power's off. I just clicked it off. Now, we're going to try to use this probe here, which I'm still not 100%. I don't have any experience with it. Let's put it that way. So we're going to go high side leakage. I'm going to touch the chassis. And we get something on the meter. Now what exactly are we getting there? So the meter says microamp leakage down here. So this is in microamps. We're looking at 300 microamps of leakage. It's got this push button on here. Push to read the true leakage current. This is it'd be better if I read the manual, wouldn't it? So pushing that button just doesn't seem to do anything at all. Now there's another one here, low side leakage. Meaning about the same thing, 300 microamps. So I think you can kind of put this together. 300 microamps, probably enough to run this meter over here. That's probably the truth. Touching it in that 300 microamps, not going to ever feel that. And as soon as you ground this, it's almost a charge. Will just disappear. It'll just be pulled down. It'll drop across something else somewhere. Be gone. That makes sense? Okay, so all in all, I'm not too worried about powering this guy up, so we're going to turn him on. We'll just crank this down a little bit. Make the meter read the voltage that we're supplying. We're starting out around, what's that, 70 volts or so. So I usually use dim bulbs in this kind of situation. I think I'm going to go ahead and do that. I'm going to revert here too. So I'm plugging in the dim bulbs system, I guess I can call it. So now the power reaching this guy is going to pass through these light bulbs. Okay, here we go. Okay, nothing's happening. Of course, I still haven't turned this on. So now, the name of the game. Undo one light. All the electricity is going to go through this bulb on the way here. If this guy's got a big short in it, the bulb will come on really bright. Otherwise, it's going to come on and go down. Something like that. We're still only running at half voltage too. So, here we go. Da-da-da. Okay, so that filament lit there just briefly. I see the light is on back here. All indications are very good. I'm going to raise the supply voltage right up to where it should be. Now a little bit is dropping on that light bulb, but it won't be much. So this guy's running at his normal voltage. Did I ever hook it up to the scope? No, I was in the midst of making sure it was going to be safe to hook it up to the scope. Let's finish that with one last step here. So I'll take the scope ground, which is hydro ground or general ground, and it's just another source of the same ground. How does that compare to these leads? So we see 3 volts. 3 volts. I don't think that's anything. 3 volts. It is nothing. We can put this right on to the oscilloscope. Here's another area here that where my antenna really started wiggling. See these two things? I'm gonna grab the two of them. Now, this one's insulated, so I'm not too scared. But any situation where I am personally bridging the ground connection between two things, no, I don't want. No, not doing that. Never. Even after all that testing, I'm still completely uncomfortable with doing these things. And that's a good thing. And how did I get so uncomfortable? I learned my lesson a few times. That's how. Okay, still learning those lessons though. Okay, so this is the output from yonder machine on the scope now. Now we should turn the scope on. Most things work better when you switch them on. There we are. What do we see? So far, absolutely nothing. So we're low here. This is pretty Okay, so let's make sure we're not on too high. We're on a low frequency, 100 kilocycles at the bottom. In the middle would be 175, something like that. We should see that on the scope, but we don't. Scope probes on ×1. Let's just pop this over to DC. Nope, no DC there. Nothing coming out of it. That's what it looks like. That's my first, well, level up. I didn't see any change on the scope at all. Okay, put it in the middle. Fine adjust. No change on the scope whatsoever. Change bands. So you can't see it in the on the video, but there is something going on there, but it's not at all what you would expect. External modulation, and it shouldn't really do anything right now. Huh. It doesn't work. How do we know that for sure? What alternate way can we test this? Have a radio operating and try to smash it with a signal from here. Quickly, I need a little radio. Okay, I'm gonna go get a little radio. Okay, got a little radio here. It's on 1,000, perfect. 1,000 would be on B, near the top. Huh. Now why don't I see that on the oscilloscope? Probably because it's a bit of a higher frequency than maybe I'm. That is a little odd. So it's wobbling like this. It's indicating there's a hum in there, I believe. If we go way up here in speed, my poor scope won't trigger. Wow, that's just an ugly looking thing there. Well, it's producing a signal here on the radio. I think it's probably a better indication that it's working. Feels very nice to tune. Let's see if we can pick it up in more places than the correct one there. That's probably exactly half. Probably putting out this frequency, and there's a harmonic coming out up here that the radio's picking up. So that would be 500. Yeah. Okay, if I go back up here, move the radio a little ways away from the signal. I'll put it over here. Now we'll play around with the adjustment here. Oh, I don't think I'm turning anything. I think the knob is sliding. Okay, how about this one? It's a little odd. Okay, what if we take this off? Well, that signal is coming out of this machine somewhere other than here. I have the case off. Maybe if the case was on, maybe that wouldn't show up. Looks like there's no output from here, but obviously the oscillator must be working inside to some degree. No output, or so it seems. What other? So I can go up here. And 1 megahertz. at the bottom. Right on the money. It's right on. Okay, we jump up to, this is 10 to 32. What I'll do is I'll put this on 10. This on 10. Any chance we're in here WWV? No, not with that. Oh, thought I heard it. Okay, I'm gonna put it over here again, about 3 feet away, and now we want this up at 10 million. So we go 10. So it should be 10 million right here. Okay, nobody coming home. I heard a click on the radio there. Put these up for what it's worth. Maybe instead of it being 10, maybe 10 is down here. Maybe it doesn't reach 10 anymore. So I'm going to put this to 11. It's 11 megaseconds. What was that? Something happened there. It's just a coincidence. I don't know if you can see this, but there's something special on the scale. Right here. The scale is continuous, but it breaks right here, and there's a dot right there. Right there. Doesn't happen anywhere else. So I'll bet you that's here's one. There's one right here. There's probably one on every band. That's probably the calibration point. So I don't see one down here. But that's probably what that is. If you can see it. It's very hard to see. Okay. So 32. I don't think my radio goes up above 30. So we can't really check this. So we'll dial in about halfway on this. Would be between 3 and 11. Halfway is 6 or 7. 6. Let's use the actual band thing here. So they've used just 1, 2, 3, 4 scales for 6 bands. And some of them are being used twice. Like right there, BD, ACE. I'm on D, 50, D. So D is between 3 and 11. So it has to be 5 megahertz. 6 megahertz right there. That's 6. 6. I can get up to 11 up here. Where the radio's tuned. Nothing. Can I bring the radio over? $11 at the top, 11 on here. $10 at the bottom. Modulation is set to external. Let's put it internal. Thought I heard it. Something right there. I'm going to zoom in right by it. there's a problem right there. This is not meant for precision work. It's quite a backlash on that control. Okay, so all that time it was working. Hey, look at that scope. How do you like that? Let me vary the output level here. No, the switch's not doing anything. And the vernier I don't think is turning. Something happening there. Okay, internal. External, so that's the modulation sound. Is this really the signal? What a mess. I mean, you should be able to get a nice sine wave on there, but that's not going to happen with the way it looks. Oh, maybe, you know, this might be the problem here. Okay, hook it back on. The radio quieted right down. Putting this on here. Okay, so now the oscilloscope shows much less. That's a monster to try to tune this precisely. So I doubt the modulation is supposed to sound quite like that. Just about in, he's going to make it retune. Just flexing this in any way. Okay, so it certainly isn't up to what this guy does. Just look at the weight difference, you know. 5 pounds, 60 pounds, 60 pounds wins. A 5-pounder is not going to be that great an instrument. Buy your stuff by weight. Well, I think the next step from here is to look at the manual, especially the initial testing process. You go through, check some voltages, stuff like that. It seems to be working. Seems to me it could work better, but I'm not sure. So I think that's really the next step. Find the schematic for this guy and study up. Okay, so I've done a read through of the manual, and you know, Heathkit equipment and the information that comes with it is very, very good. So here's the schematic that goes with it. One of the interesting things is the RF oscillator is either this tube or this tube, depending upon which band you're on. So I think only band F uses this tube to create its oscillations. The rest of the time it's here that the oscillations are happening. So that's kind of interesting. I guess obviously when you're switching bands you eventually switch to this other tube somehow. And this is the audio oscillator here, producing around 400 Hertz. That's what they promise. And then all that heads to this tube to be boosted and then delivered to the output of the unit. So I think we should really start with the power supply. Oh, what are all these notes? All resistor values, all capacitors. Circle indicates voltage reading. So interesting. They have the voltage written there, but then they have a circle with the same voltage written here. So all I got to do is find those circles and do the test. All voltages DC positive unless marked otherwise. All voltages measured from point indicated to chassis ground. except AC voltages on power transformer windings. Voltage readings taken with an 11 megohm input VTVM. Well, that's what this is. Oops, over here. That's what this guy is. I thought it was 10, but maybe it's 11. And that's what we're going to use. That's another Heathkit. I got a lot of Heathkit stuff. I guess that's kind of inevitable when you do this kind of thing, especially vintage. Run a vintage shop, it's going to be full of Heathkit equipment. That's what's going to end up happening, which is not a bad thing at all. Now, we're down here. Voltages may vary 10%. All switches shown at full counterclockwise rotation, except switch S3, which is at full clockwise. S3. Why don't they call it, why don't they give it an English name here? S3. So all switches at full counterclockwise rotation. Put that there. Put that there. No, we don't know what's going on with this yet. I'll put it there. There. All switches showing full counterclockwise, except switch S3, which is at full clockwise rotation. Please, which one's S3? 1, 2, 3. It's probably this. I'll find out. I'll find out. Switch lugs with the same numbers on decks AR and AF are connected together. 12 to 12, 11 to 11, etc. I don't know why they're telling me that. Star, one asterisk, voltage measured with band switch S2 set at F. S2. So S2 is the band switch. Thank you. Is that the one that they talked about up here? S3. So the band switch is S2. All voltage measured with band switch. So they're telling you to turn everything counterclockwise, but when you do that one test, you switch the band switch. Voltage is measured. So we'd have to look in here and find. Okay, fine. Double asterisk. All sections shown here are viewed from the front panel. Switch shown in band A position. So that's band A. Switch is shown in switch on here is shown in band A. Okay, didn't get too much out of all that. I think I'm ready to go though. No, don't put that away. I'm going to need this. Okay, so I'm going to start with the power supply. And we really want to go right to this one. 155 DC, top of this capacitor, just past the diode. Well, the diode's pretty easy to spot. It's way down here. Yeah, you know what? This guy can kind of sit on his side here, I think. This is a better way to do this. Yeah, that's much better. Put this down here. That's much better. Okay. So there's the diode. So one side of that diode, it's going to be this side because the other side is hooked up to these red wires. 150 volt scale, expectation is 155, so it should throw the meter right over. Oh, that's just it, it turned on, didn't turn it on. Oh my gosh, I've got the power to it. Shame, shame, shame. Okay, we're going to get rid of the dim bulb in the circuit. And we're going to hit this guy with 109. Go up a little higher here. 113, 114, that should be good. Well, we're going to do these voltage tests. Maybe I got to get this just a little more accurate. Here, doesn't it say on here? Probably doesn't. 117 seems to be the number that as most often referred to. There we are. That's good. Okay, first test. Watching the meter. Just over the one, looks like 160 actually, but I mean, how accurate is my meter? So it's all there, I would say. That's 155. Now we go across it to this resistor. Come on here, across the resistor. On the other side of the resistor, we should see 130 volts. It's dead on 130. That's right on the mark. And not that my meter's that accurate. So power supply's looking good. There's nothing to it anyway. Transformer, diode, 2 capacitors. How can you go wrong there? So that voltage should be all through here. Let me work our way upwards here. Maybe look at the screen and plate voltages. So there's 4 plates, 1 screen. So we go to this tube, 12AT7. Oh, which one is it? I do not like picking up things that are operating. Okay, 12AT7 is that tube there. And got an asterisk there. This is the part of the tube that only works on the F scale. So we'll go with this part. Plate number 1, or pin number 1, 65 volts. Pin number 1. Pin number 1 would be here. So we're looking for 65 volts. We get 58 on there, 57, 58 on there. Sounds, you know, 10%. Sounds close enough. I mean, it's there. So we could flip now to F and look for almost the same voltage over here. For some reason, versus slightly lower. So we'll flip to F. That's F. Pin number 6. Pin 6. 1, 2, 3, 4, 5, 6. We get 58 volts there, about the same. Okay, that's good. Good, 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 good. Now, what other stuff can we find on here? We can look for a -4 on pin 2. -4 on pin 2. Okay, so that's just 5 volts now, full scale minus. Pin 2, better hit pin 2. Pin 2 is right here. Didn't see it any. Oh, we're on F. We gotta come off F. Back onto A. Pin 2. Oh, went right over. So on 5 volt scale, it's a little more than 5 volts there. What do we got? 6 volts. 6 volts. And this is saying it should be 4 volts. 4 volts, 6 volts. What would make this go high? I don't really know. Where's it getting this voltage from? It looks like it's a grid leak system here. So I'm not going to worry about it. It's there. There's something there. So unless there's some reason to worry about it more than just the measurement. And the other part of the tube should find minus 0.75 volts on pin number 7 when we're on the F. Pin number 7. 4, 5, 6, 7, 8, 9. This is 7. Very, very small voltage there. It's supposed to be 0.75. 0.75. Well, you know what? That's pretty much it. That's 1.5, 0.75. Yep, it's right on. It's right on the money. else up here worth reading? We've done the plates. Cathodes are at 0. Nothing more up here. So that guy is good. Now we'll take a look at this other tube. Any asterisks in here? No, because this is the only one that gets switched on band F. Band F. We're stuck on band F. Go back to band A before it's too late. Okay, so we'll take the 2 plates on this one. This tube. So first plate, 70 volts, pin number 1. 70 volts, pin number 1. Okay, oh, 70 volts. Okay, 150 volt scale, so halfway up. And because I said a number, I can't remember. Pin 1. How can you forget pin 1? Pin 1. Pin 1 would be this one. Right here. Okay. Polarity right. There it is, halfway up. Okay, so we're actually reading about 85 volts there. And supposed to be 70, but 85, 70. Okay, the other should be pin 6 now, 125 volts, pin 6. So 150, 125, going to put it up here. I said a number. So, you know, apparently I've only got one shift register, and whatever I put in it, you know, knocks out the earlier thought. So, 6. 6. So that'd be 9876. This would be 6. And we're right over at 125. And the magic number is supposed to be, wasn't that 125? 125. Screen voltage of 130 on pin 7 of that tube. Screen voltage, pin 7. There it is. And it's coming up to just under 130. 130. It's kind of got to be 130 because it's just a wire from here to here. Okay. Now, grid voltages. Do they give them? 0. So this one's got a cathode bias system. So let's look for this voltage. 2.5 volts positive on pin 9. Pin 9, that's the last pin. Pin 9. 2.5 volts. That should be straight up on here. Pin number 9. That's this. Straight up. Everything's good. It's good, good, good. What's left? What's left? What's left to check? 1.5 volts on pin 3. Now when I listened to this, the modulation coming out, it sounded like crap to me. I may have to investigate that separately. Voltage, pin 2, minus 0.2. Pin 2, minus 0.2. Pin 2, 1, 2, minus 0.2. Not doing much on the meter. Okay, did I get it right? Does this have to be on F by any chance? There's no asterisk, no nothing. 0.2 is a small voltage. This is this way. Yeah. Did we find something wrong here? Okay, so this is another, there's a resistor 100K here. Oh, it goes into here, yeah. Boo, boo, boo. Gets mixed up in this thing. This is the control, which is supposed to be all the way to the left, but I believe the actual potentiometer is frozen and the knob is rotating. Maybe I gotta straighten that out, because maybe that's disturbing this reading. Let's try it again. It's pin 2. Nobody home there at all. Teeny tiniest little voltage there. Okay, so let's deal with the stuck shaft. The stuck shaft. This guy. Is it just a slipping knob? It's not so much that the shaft is stuck, it's just the knob is slipping. I don't think so. Here we are. Pretty tight. Let's put some power on it here. Wow, that is tight. Okay, so chances are it's just tight in this shaft right here. So I'm going to get out my magic elixir. I'm just going to try to shoot it right in the shaft here. Must be a left-handed can, that must be the problem here. What's with all the precision there? Take careful aim and then blast it with a shotgun. What's all this? Well, what's all this gook? Where'd that come from? Did I didn't hose anything in here. Where did all that? Did I do something and then forget it? I don't think so. Well, I can see the mess I made, but who made this mess down here? What's going on? There are people who use WD-40 for cleaning stuff like I'm doing right now. I can't really say I've used WD-40 for cleaning things, but what the heck happened there? That oil just appearing from nowhere. I mean, why didn't it drip out the bottom? Why? Maybe I shot some sideways there. It must have over here. I feel like a magician's trick or something. I don't know. It looks like it's loaded with oil. Let's take this knob off too. Let it reveal its secret. Now, did you notice I had my hand on the ground of the meter and my hand on the chassis at the same time when I separated those things? Shame, 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 shame. There we go. I don't get that. Is this thing loosened up at all? And so I'm not sure which, it could be at the limit. When you use a big tool, you can't, it's right at one limit. You can't feel it. Now it's turning as free as can be. Just a little bit of oil in the shaft there. Might as well put it back on. That's turned down, so we'll have a point like that. No, that didn't work. Can't get it tight. There we are. Okay, I'm just going to move this a little bit this way. Now these have no metal liner in them. They're all plastic. Don't be tightening that screw too far, he's saying to himself. This has a flat side too, because it's a snap switch. So they know it's going to take a bigger beating. And mysterious oil. This is really on the flat. Lovely. This one slipped in too. holding it. Come on, guy. They're all screaming out. Okay, no need to do precise aiming here. Oh, that was pretty good. Same problem. I can't tell which way the switch is actually set. Let's put the knob back on. Yeah, so if your knob was slipping and the problem is the shaft is sticky, but you just keep tightening the screw on this, trying to lock it down more and more, eventually it's just going to break this in here. Especially the wooden ones. If you have a wooden knob, watch out. A lot of them have a brass or a metal insert here so they can take the pressure, but some can't. You'll split the knob. And you know, knobs are what you see. So we're just going to tighten this temporarily and then set the switch and then correct its position. Oh, that's good. Got it good anyway. Just a little bit tighter. So this is a switch, but the shaft had no flat on it. So not very consistent with how they've done it. That's good. That switch is solid. Slippery. Ooh. Some more goodies under here, but I don't think I'm going to put them under the microscope this time. I didn't see any funny orange things. Really? Fallon got caught under the other knob. Goodness knows where it went. No flat spot. Okay, no tendency to slip. So now we got control here. Well, I adjusted this the last time. This didn't do anything. So output here is going right through this capacitor, and the output down here, well, it's going through a more reliable type of capacitor here. This guy's up here. I'm just, you know, I don't think these are bad enough. There's another one over here. I just don't think they're bad enough to be worried about. And this must be the filter capacitor here. I gotta knock the tube out. Ooh, did I ever knock it? ECC 81. Put it more carefully like that. So I haven't found any reason for it not to operate 100%. Dirty switch, dirty contacts, dirty controls. Let's try it again. Let's try this guy again. Okay, he's in. On there. There we go. Now what are we trying? We're going to try to look at it on the scope again. pretty sensitive, 0.5 volts per scale, per division. We're set to external modulation. This just controls the modulation level. We're looking for a lot of output. We're just down here on the low frequency, about middle of the band. And it just looks like nothing up there. Is there something, maybe this cord is bad. Before I thought it might be picking up the signal with the radio coming out of the back of this unit rather than out of here. Let's see what's going on here. I don't think anybody likes these kinds of connectors here. They're called Amphenol, I believe they're called. Hard to believe it didn't make contact. Scope looks the same. Okay, I'll try and take it right off the connector here. I'm just going to hold that like that. I'm going to go like that. I don't see a thing. Oh! There is something going on there. Get a better ground. Oh, now I got a screen full of stuff. So we're in fairly low frequency. Okay. There's what's coming out of this baby. Holy smokes. You call that a sine wave? Wow. Okay, let's fiddle with some... now, why can't I see that on the end of this cable? I can tell it's butted up in there. Let's go on the ground. This goes on the output. Nothing. Pretty rugged looking cable. But we get nothing. What if I put the ground on here? We get that. Ooh. Oh, you know what? Okay, so what's that saying? What is that saying? That is saying the ground is not working through this cable. Just looking for continuity here through the cable. Okay, the center contact. Center contact. Contact. Let's check the meter. Hey, what's going on here? Yeah, I'm going to have to do a number on this meter. Very careful. Look at it. Come on. What's happened here? Did the cord, I got the right chords? Once in a while I'll grab a test lead from another instrument. Be working away with. Now we're in business. You ever do that? Type on the wrong keyboard, grab the wrong mouse, wonder what's going on. Now that makes more sense. Okay, that's not surprising. Well, what about this ground though? It should be just as good. Son of a gun. So is it just, this just isn't happening? How can that not be happening? So we can go from, put this in here. And now, so the meter's on the ground wire here. What about that? Nothing happens. How's that happen? How do you get that? How do you get that? How does that happen? Okay. On the ground here, though, down here. Ground lead. Okay, outside of it, it's really hard for you to see that meter, isn't it? There, that's better. So grounded here. Now what about the chassis? Grounded there. Well, what happened? Just making the contact on the aluminum is lousy. So there we are. So cable test good. All connected. What's the problem? Should see the same thing. And what do we see? What is happening? Come on, man. How do we know the... Well, so yeah. Right. From the ground. The center conductor not making contact through the connector. They've got it. Huh. Well, the way they've got it arranged, the lead on the back of the connector is covered with insulation. There's actually no access for an ohm reading through there. Son of a gun! Come on, I must be able to work it in there. Let's try. Okay, so I'm going to put this lead on the center conductor. And I'm going to try to look for it back here in amongst all this insulation. Anything happening there on the meter? This is a long shot. Maybe if I use, I've got a clip here that might get a piece of the wire. Yeah, I think it did. Okay, so we clip here. Okay, so at this point, let's say it's open circuit in here, unless I've done something wrong with the meter. So I'll wiggle this contact here. The unit's still on too while I'm doing this. Well, it's saying there's no continuity through the lead here. That's what, but does it know what it's talking about? Because it may not have made metal contact there. Son of a gun. This is the silliest stuff. Yeah, down in there. So there's the two connectors, one here, that's the one we're interested in. The lead comes out on just with a covering to a capacitor. And there's no exposed metal there. They did a good job of that. Can I not? Maybe sometimes you can just push this insulation around. You know what I'm going to do? Because we don't need it on during this. I'm going to save my life and turn it off. Can we push this guy back a little bit? Oh, it's very soft. It's very, very soft stuff. Let's get in there and eyeball a connection. That's got to be in contact with the wire there. That's my estimate. Sit there. No contact. Okay, let's double check things. So I got the meter hooked up. Let's get rid of let's simplify this. Get rid of the scope here. And connect to the meter. Okay, so this is hot lead. No contact. this connector tightens up pretty good though. It's supposed to be tightening up by pushing the two contacts together. Okay, once again, let's check continuity right through it here. Oop, wrong lead, wrong lead. Did not make contact. Connector shot? How can that be? Come on. It can't be the case, can it? I swear I'm on the wire there. Oh, there we go. Finally. Okay, yeah, definitely. Okay, just as I expected. No problem. So it comes down to this contact not making contact. Hard to see how it couldn't. Didn't screw it in tight enough. I wimped out. Feels like I'm crushing something in there. Okay, so ohm meter again from center conductor. And try to make contact back here. Oh, there it goes. Okay, so okay, finally. You know, you got to prove these things, or you may leave something, you know, happening that. Oh, you leave assumptions. That's what it is. That's what I want to say. Trying to remove the assumptions. Okay, so how come no output? How come the output controls don't change the level up and down? Let's put this back on the scope, because maybe I did something through all this. Maybe I fixed it. That. We're good to go. This is on low. This is all working. And maybe. Hit the switch. There we go. Switch has been hit. Come on, Scopey, you're on, let's make it more sensitive. 0.1 volts per division. It's definitely the rate. It's all right, everything is right. Take this out of here. It just doesn't get any simpler. Okay, yeah, lights on, everything's good. I'm watching the scope now. Why would it show nothing on a scope? Oh my god. Have we been looking, you know what? Maybe we were looking at the upper display on the scope. Is that what's happened here? I'm looking at the wrong display. No. That's the lower display for sure. I don't get it. So if I hook the scope directly to the terminal, it seems to show up. So saying that this cable is absorbing all the signal? Come on, that can't be the case. Let's go back and look again. Now I got that funny signal in here because I had, well, I don't know why. Actually, funny looking. Totally distorted thing, so look again. This time I'm going to ground it. Oh, look up. Just get back a little bit. stand back, everybody. This is high, this is full, this is on the lowest frequency. So you know what, there is something there. But maybe it is so big you can't see it. Doesn't seem to be the case. Probably I had this clip on the chassis. It probably didn't make any contact, and so on the scope you see an ungrounded signal there. It's baloney. That's probably what I saw before. Is it just the output is so blazingly low you can't see it on a scope? I can't imagine that. Okay, so this is the end of the road of sensitivity on this scope. Well, there certainly is something there now. Okay, so let's go back to this, because I think this is working, and I think the cable is working. Well, it's different. It looks, oh, these might be zero contact. Huh. So it looks like a big 60 cycle hum, and with RF on top of it here. But when you get up here, there's no nice, neat looking sine wave. Now my scope isn't triggering properly these days. Now that's definitely not the signal. That looks more like a hum. A hum. Let's look at the capacitor on the scope. The filter capacitor. Oh, it's up on the top here. Oh, I got a tube half out. Son of a gun. Was that the whole? Oh. Oh. Hey. I haven't tested the tubes in this yet. You think in an instrument like this, the tubes are going to be good because they haven't had any mileage. Well, it's glowing. Let's just, I had that tube partially knocked out of the chassis. Let's just see if that wasn't the whole thing I've been chasing here. Oh my gosh. Maybe it was. I don't think so. No, what we're seeing on there is not. And you can see what looks like a 60 cycle hum, I would guess, and then a bunch of stuff on top of it. What a crazy machine. Could be these are not doing anything because there is nothing here to do something to, because there's no output from the tube in question. How unlikely that is, I think I got to test them. Well, here's something interesting. I just shut everything off in my shop and went outside for a few minutes, came back in. I look, why the scope is still showing the very same signal situation. And this isn't even turned on. So I think is zero output from this guy. That's what I think is happening.